Welcome to Study Loop.
To determine the horizontal and vertical components of the forces at pins A and C of the two-member frame, we're going to calculate the equivalent point loads for the distributed loads and apply equilibrium equations to solve for the reactions at the supports. So for the horizontal member AB, the load distribution is 500 newtons per meter over a length of 3 meters. The equivalent point load would be 500 times 3, or 1500 newtons. This load acts at the midpoint of AB, which is 1.5 meters from either end. For the vertical member BC, the load distribution is 600 newtons over 3 meters, and that would be 600 times 3, or 1800 newtons, and load acts at the midpoint of BC, which is 1.5 from either side. And the load distribution is 400 newtons per meter over a length of 3 meters for member CD. And so the force is 400 times 3, or 1200 newtons, and it acts at the midpoint of CD, which is 1.5 meters from either end. And we need to apply the equilibrium equations to solve for the reactions that supports A and C. The sum of the forces in the horizontal direction is 0. And assuming that A sub x and C sub x are the horizontal reactions at A and C, that they must be equal to 0. And the sum of the vertical directions has got to be equal to 0. And assuming A sub y and C sub y are the vertical reactions, then A sub y plus C sub y has to be 1500 minus 1800 minus 1200. It has to be equal to 0, which means A sub y plus C sub y have to be equal to 4500. And the sum of the moments about point A have to be equal to 0. And taking moments about point A, negative C sub y times 3 plus 1500 times 1.5 plus 1800 times 3 plus 1200 times 4.5 has to be equal to 0. And so C sub y would have to be equal to 4,350 newtons. And substituting this into the force equation, then A sub y has to be equal to 150 newtons. The sum of the moments about point C have to be equal to 0, and taking moments about point C, confirms that the moment calculations are consistent, because we're going to get 13,950 equals 13,950. For horizontal forces, since A sub x plus C sub x equals 0, if C sub x is to the right, then A sub x must be to the left. Thus, the horizontal and vertical components of the forces at pins A and C. For pin A sub x equals negative C sub x, and A sub y equals 150 newtons. At pin C, C sub x equals negative A sub x, and C sub y equals 4,350 newtons.